Well, greetings, Mr. Kolazar's class. We're going to start into section 6.3 in our notes, blocking the elements in electron configuration. And so as we're going today, a couple things that you'll need out. First off, your chemistry notes, and then secondly, to grab out your packet of worksheets, and then to turn to the page in the worksheet that's labeled blocks of the PT. So I think it's about the third or fourth page in, blocks of the PT page. It's got some empty spots on here. You'll need that as we're going also. So make sure you grab both of those out before you continue. Now our first part today is we're going to look at focusing in on the valence electrons. Valence electrons, remember the electrons that are in the highest energy level. We also could call that the outer energy level. So what we've done is chose group 1's elements: hydrogen, lithium, sodium, potassium, and rubidium. And if we were to look through, just as a refresher, each of the electron configuration: hydrogen, 1 electron in the first energy level, the 1s1. Lithium, 1s2, 2s1. Sodium, 1s2, 2s2, 2p6, 3s1, and then continuing our sodium to potassium to rubidium. What we're looking at here is, first off, that all of the group 1 elements end in S1. 1s1, 2s1, 3s1, 4s1, and finally to 5s1. And so as we're going, our key idea for everybody in group 1, all elements in the same group have the same number of valence electrons or number of outer electrons. What is the relationship between the elements in the group and the group number? Well, for group 1 and 2, they're the same. Group 1, 1 outer electron. Group 2, 2 electrons in the outer energy level. And then if we were to look through groups 13 through 18, if we subtract 10, 13 minus 10 is 3, all the way through 18. 18 minus 10 is 8. That would be for all of our main group elements. All of those elements are going to have that number of outer electrons. So anybody in group 13 would have 3 outer, group 14 4 outer, all the way to group 18 8 outer electrons. Our second pattern we're going to look at is if we were to look at elements in period 2. So lithium, beryllium, boron, oxygen, and neon are all elements that are in group 2. And what we're going to see is that all of them, 2s1, 2s2, 2s2, 2p1, 2s2, 2p2, 2s2, 2p6, all of these elements that are in period 2 all of the electrons that are filling the outer energy level are all in the second level. So as we're going, what do all elements in the same period have in common? The valence electrons all belong to the same energy level. And what's the relationship between the elements period and the number of valence electrons? The period number is the highest energy level. So that period number, the numbers on the left-hand side of the periodic table, are going to tell us the energy level that we're at, or that the electrons are filling. So our periodic table is going to be blocked into different sections. So blocks of the periodic table, our S block, is going to be on the left-hand side to represent that the last electrons, or the outer electrons, are filling the S block. Remember, the s orbital over here, plus we include helium from this side. Helium kind of would go over here a little bit, but we'll talk about as we're going why we actually keep helium here instead. The P block for SP, D, and F are the elements located in the right-hand side here, and then our D block, and finally the Lanthanides and Actinides at the bottom, is our F block. Now each of these blocks represent the last sublevel being filled by those electrons. So if our element's over here, the last electrons are going in the s orbital, or the s block. If they're over here, the p orbital, the d orbital, or finally the f orbital. So this is kind of where our shape is coming from our periodic table. A couple of the odd elements out. Hydrogen, element 1, fits over here. Even though it's a gas, non-metal, where the rest are metals and are very reactive, hydrogen fits here. Let's get that correct, sorry about that. Hydrogen fits up here due to the fact that it has one outer electron. Helium, another unusual one. Helium also part of the s block, even though it appears on this side. Helium is filled 2 valence electrons instead of 8 like everybody else has that's in group 18. But helium with 2 is a full outer energy level. Chemically it's very similar to the rest of the noble gases. So a couple of the odd elements there. So what we're going to look at today is on that second page of your worksheet, the blocks of the periodic table. There's going to be a few things that we start looking over as we're going forward. First off, our elements that are in our first 2 groups, we're going to know that to be the S block. Our second block on the far side, our main group of representative elements are either the S or the P elements. This will be our P block. In the center, our D block, and then finally the F block. Remember SPDF, some people drive fast. Whoops, some people drive fast. Now, a couple things to note. Down here, we have what are known as our Lanthanide and Actinide series. We're going to look at them in just a second. So, a couple numbers to remember. Our group numbers to put in go from 1 to 18 across the periodic table. Now, these numbers we'll have you put in represent which group, and if we're a main group element, that would give us the number of outer electrons that we have. And then down the side, our period numbers are going to tell us which energy level that we are in. Now, down at the bottom here, group 6 continues here and 7 here, our Lanthanides and Actinide series. And actually this kind of would actually come up and would fit in here. And this would fit in up to here. So this section actually fills in and fits in up to here. So as we're going to be seeing this series at the end here. So what we're going to look at today is 3 things to write down. First off, we're going to look at the energy level that we're in by the period number we're in, what block on the periodic table we're in, and the elements traveled through, or the elements that we're passing through to find out that electron configuration. So we're going to start up at the top with hydrogen. Hydrogen element 1 is in the S block, so we're going to call it our 1 energy level, S for the shape, and then we have 1 electron in it, 1. So hydrogen 1s1. Now from there, moving across the table, our second one, remember helium, element 2, we said was also the 1 element on the side that was in the S instead of the P block. It's in the first energy level, 1, S orbital or shape, and we have 2 electrons, so 1s2 for helium. Now from here, we'll stick with just the rest of the S block. As we move down, we would have the 2s, the 3s, the 4s, and 5, 6s, and 7s blocks. So everybody that's in the first two groups or the first two columns on the periodic table would all end with their energy level being the period that they're in. And then from there, if you are in the first group, a 1s. Or if you're in the second group, would all end in 2s, 3s, 4s, 5s2, 6s2, 7s2 as we're going. Now if we move across the periodic table, once we get past beryllium and moving on to boron, we enter into the p block. Now once we get into the p block, we're in the 2p, and our first element would be 1. 2p2, 2p3, 2p4, 2p5, 2p6 would be our final one for that energy level. And once we've filled that energy level all the way up, then we move to the next energy level and we move into the 3s's and continue on to the 3p's, and we continue across and we move back down to our 4s's, and this is where we have our first change. It is right here once we get to the d's. What we need to do is to write in just one key note. When we get to the d's, the d group is going to be n, the energy level, minus 1. So whatever energy level n, we could even say down here n minus 1, whatever energy level we're in, if we're in the fourth period, 4s, we're in a minus 1, so 4 minus 1 is 3, so this would be our 3d. So we'd enter in 3d1, 3d2, 3d3. Now remember, our next element, chromium, was one of those wildcard elements that we had from before, and instead of going 4s2, 3d4, it steals one, and so it changes and has instead the 4s1, 3d5. So chromium is the one exception, and then we'd continue across 3d5, 6, 7, 8, and then our other exception was copper, where copper had 4s1, 3d10. So as we're going, those would be our two exceptions, and then we would finish out with 3d10 over here before heading back to the 4p's. So as we're going, the pattern continues across the 4p's, and when we get to the s's, the 5s's, this is where we get back to the 4d's, go across the 4d's to the 5p, across the 5p to the 6s. 6s is where we're at now. Once we get to the 6s, this is where our last change occurs, and from the 6s we first jump down to our lanthanide and actinide series, a lanthanide group named after the first element, and our actinide group named after the first element in each of these groups, where we jump down into the F block. Now our F block is going to be n, the number, minus 2. So when we get to the F block, we're at the 6th period, so 6 minus 2, all of the elements that are going in here are going to be part of the 4F. So as we go across, the F block had 7 orbitals, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 blocks fill that, so we'd have 4F1, 4F2, and it would continue all the way to 4F14. Once we were done there, we would move back up to to our 5Ds, moving across 6P, and moving across and traveling through to our 7S's. From 7S's, we'd move down to our actinide series. 7 minus 2 would be the 5Fs, back up to the 6D, and all the way across to the 7P, where we'd finish out with the rest of our elements ending here at 7P6. So our shortcuts will be coming up shortly with describing where we get our different elements from. So if we were to pick out an element on the periodic table, we'll say sulfur. We'll pick out element 16. So sulfur will be our first practice problem. And we'll do sulfur maybe up at the top of this page. So first off, we've got to find out the energy level sulfur's in. It's in the 3rd energy level. Second, we're going to figure out what block it's in. It's in the P block, so 3P. And then from sulfur being there, what we're going to look at is the elements we traveled through. So we start out, we went through hydrogen, helium, across through the lithium, beryllium, rest to the P block, back to the S, and finally finish up here. So to show those elements, 1s, 2, so for sulfur, we're just going to write sulfur at the top of this page. Would be 1s, 2. Second row, 2s, 2 is filled. Our 2p, 1, 2, 3, 4, 5, 6. Our 3s, 2. And finally 1, 2, 3, 4, 3p, so 3p, 4 is where we would end at. So sulfur's electron configuration, 1s2, 2s2, 2p6, 3s2, 3p4. So as we're going forward, any element we pick out on the periodic table, we can go through and find out what energy level it's in, or the period, what block it's in, and then by going through the elements traveled, we'll be able to find out where it's actually at. We'll be able to use this information to find out our shortcut method, which we'll be talking about in class shortly. Last information, discussing the S, P, D, and F blocks by the element and where they're located at. S, period 1 and 2, part of our main group, the s orbitals. P block is groups 13 through 18, our main group. 3 through 12 groups are our transition elements, known as our D block. And the lanthanide and actinide, the two blocks at the bottom of the periodic table, our f orbitals, can be known as the inner transition elements. We'll be discussing these in class and showing our shortcuts coming up.